Hello everybody, welcome to TS Boost. Today we're going to talk about p-values. It is a classic question which is often asked in a lot of data science interviews, like especially the top firms. They love this question, and there are two versions of this question. Firstly, they might ask you like explain p-value to me with all the technical details, but a more common question I would say is explain p-value to somebody non-technical. So let's see how we can tackle these questions, given it is a very important concept. Okay, so before I begin to explain the p-value concept, I'm assuming you are familiar with the concepts of hypothesis testing and statistical inference in general. So statistical inference is a process you use to infer something about a population, and because of time constraints or money constraints, sometimes you're not able to run the experiment for the entire population. You instead take out a random sample and observe the sample statistic. Based on central limit theorem, you know that the sample statistic will follow a normal distribution. Now let's talk about the null and the alternate hypothesis. At this time, I'm going to use an example. Let's say you're trying to study if a coin is actually biased or not. What do I mean by that? Like typically when you toss a coin, you expect 50% of the time it will show heads, or in other words, 50% of the times it will show tails. That's the characteristic of an unbiased coin. So this becomes my null hypothesis to start with, which says that the coin is unbiased and you should observe 50% heads when you toss the coin multiple times. Now I conduct this experiment on 100 flips, and the null hypothesis in that case will be that 50% of the times you actually observe heads. What happens is you flip a coin 100 times and you observe that 90 out of the 100 times you actually got heads, which is like an occurrence rate of 90%, which deviates a lot from your expected mean. Not expected, but if had the coin been unbiased, you would have observed 50% heads. Now there are two possibilities. This 90% could actually be because of the randomness of the event, or the other reason is it could actually be due to the biasness of the coin. Now using central limit theorem, we can actually calculate the probability of observing an extreme event. In this case, the extreme event is observing 90% occurrence rate for heads. Now what is the probability that this extreme value is actually happening due to random chance? And this answer my central limit theorem can give. This probability value is called as p-value. Now if this p-value is low enough, we can confidently say that it is very unlikely that such an extreme value will be observed because of chance, and hence we can reject the null hypothesis. And the cutoff that we use, which is the industry standard, is 5%. It's also called as the significance level, or alpha, which means that this is the margin of error I'm comfortable with. If the p-value is less than 5%, I can reject my null hypothesis, and which will give me some sort of evidence that it is not happening due to random chance. So this is what p-value concept is technically, and it can be used in medical trials as well. Let's say you launch a new medicine which lowers cholesterol. In this case, your hypothesis will be that the sample of users who received your medicine, they should ideally have 0% reduction in cholesterol. But if after the treatment you do see, let's say, 5% average drop in cholesterol levels, you can then look at the probability of observing this extreme value and see if the p-value is low enough. If it is, you reject the null hypothesis that the medicine has no effect, and this gives us an evidence that my alternate hypothesis could be true. That is, the medicine probably works. Now, in the interviews, you can use this framework where you first talk about an analogy. It could either be the flip of the coin, it could be the medicinal trial, or any other analogy you have in mind you feel comfortable talking about. Explain to the interviewer the null hypothesis and the alternate hypothesis, and then talk about, like, if you observe an extreme value, what is the value corresponding to it. And extreme value assuming your null hypothesis is correct. For example, in medicinal trial, your null hypothesis will be that the impact was 0%. But if the observed value was quite extreme compared to 0%, let's say 15%, what is the p-value, or what is the likelihood of observing this extreme value just out of random chance? If that value is low enough, then we have a surprise factor, which means that it is very unlikely that this result will occur due to sheer randomness of the event. And it also implies that we have now sufficient evidence to reject our null hypothesis, and we can with some confidence conclude that probably the alternate hypothesis is true, or probably the medicine works. So hopefully this framework was helpful, and next time you will be able to explain p-values with confidence. Thank you for watching. Like and subscribe.